All right, we are on. Let us begin. So, again, attendance, please do that. And today is the culmination of every programming lecture we've ever had. We are going to write Pong in Python, finally. We are so excited, I hope. So let's open up idle, get ready for the day. I'm going to write one big file. That's essentially what's going to happen. And I'm going to pull open the things that I was working on last time. So we had the paddle program, and we had the to-be bounce program. And so what Pong is I'm just going to combine these, right? We have our 2D bouncing, so that's our ball with a random speed direction. That was pretty horizontal. Let me show you that it really is random and diagonal, two-dimensional bouncing. So that's our ball for Pong. And it's bouncing off the walls right now, which is pretty much right. Only have to change a few things there. And then our other program was the program that controlled our paddle. All we have to do is somehow combine these. And this is keeping track of my key presses and moving that paddle based on my key presses. And if I type up and it's already at the top, it stays there. It doesn't go any further. Same if I type down and it's at the bottom. We made sure to not go past the top or the bottom. This is supposed to be bottom, I guess. There. So, the question is, how do we combine these? And actually, this, Pong in Python, is in fact your final programming assignment. So you can just copy what I do today, and that is your final turn-in assignment for programming. Isn't that exciting? And therefore, I'm not going to be giving you the files that I write today. You'll have to either take a picture while I'm coding or watch the video. Okay? So this is your last programming assignment. Wink, wink. We are finally going to make Pong in Python. So we got to combine that paddle program with the ball moving program, and together we have Pong. All right. So let's do this. I have one real meaty slide, and let's make it happen. Let's attempt to combine all these things. So the first thing that we did last time was we made sure that the paddle didn't go out of bounds when it hits the top or bottom wall. I guess that should be an it, even though it is a turtle. So how did we keep track of that? We had to make sure that here was our game board, our bounding rectangle. We had our paddle, and we pressed up and we pressed down, and it moved a little bit, but we had to keep track of those upper and lower limits. This is going to help us bounce off the paddle in a second too, remembering all this. This is y equals 200, this is y equals negative 200, and we were trying to move the paddle based on its coordinate, and because it is a turtle, secretly, it is relative to its center. And so because of the length and width of that paddle, we had to not say exactly, oh, if you're less than negative 200, if your y is less than negative 200, then you're outside the screen. No, we had to worry about the center. And so if you're at the bottom, the center is above negative 200. And we decided that it was negative 140 and positive 140. That were really those bounds. So like if the paddle was up here, that means it was, the center was y equals positive 140, okay? And so that's what we don't want it to go above and below, okay? So we used an if statement to see if, hey, did we hit it? I'm changing him to it. If we hit that, if the paddle hit the top of the screen, and if so, we don't let that paddle go any farther, okay? Same for the bottom of the screen, okay? So do you remember that? Any questions about how I did this, why I needed to do this, how I calculated these things? And we set up those key presses, and we were off to the races. And apparently, we move by 10 units at a time, so that's important to remember. Okay, so now let's combine these. Let's combine these two programs. The secret is, well, we have to worry about something. The turtle, remember, in the first program is the paddle. In the second program, the turtle is the ball. We only have one turtle. What do? We need two, okay? We need to make two turtles, and that will solve this issue, okay? So we've been saying turtle.goTo, turtle.forward, and that's been moving what I would like to call the default turtle. Every time you use the turtle library, well, it's based around turtles. It gives you one for free at the very beginning, and then you get to use that one if you'd like, but you can also make more. You can make more turtles, multiple turtles on your screen. So let's go to the library real quick. And let me show that to you. Actually, some of these example pieces of code have been using multiple turtles, I think, secretly. So if you want to make a new turtle, here's what you say. You say turtle.turtle with a capital T. That is a function that gives you back a new turtle. Oops. So let's search for that. Turtle. Maybe I should search by capital letters because it's not going to find it real quick now, is it? There it is. Turtle. Turtle.turtle. Or turtle.turtle. Is it going to show me anything? Or how about this? No, that's not very useful now, is it? There it is. Okay, here's an example of making a new turtle. That's good. At least there was one on the page. So you call turtle.turtle. For a reason, that one's not using the turtle dot. But we need that turtle dot. And then you set it equal to a variable. You make a new turtle, you have to put a place to store it and to be able to talk to it later, ask it to move around. So we put our turtles into variables. Okay, so I'm going to do this for the paddle. I'm going to say paddle equals a new turtle, turtle.turtle, open parenthesis, close parenthesis. And then I'm going to say ball equals turtle.turtle. So that's going to be how I combine these. Okay, so let's make that happen. Let me do my best. I'm going to make a new file, and I'm not going to save it anywhere that you're going to get access to it. Because remember, you're coding this up yourself. Can I save it in like my downloads folder? Sure. Or maybe on my desktop. How about pong.py? All right, so now you're not going to have it. And let's bring in, I don't know, the older program was the 2D bounce program. So let's bring that in. And let's see what we got to do. Let us first change, instead of saying turtle dot everywhere, we have to make a new turtle for the ball, okay? Because this is just the ball program right now that I've copied and pasted. It's just this one. Whee! Okay? So with that, let's make this happen. I can use the default turtle to draw the bounding box. That's fine. Everything's okay there. But once I get to be the ball, I have to make a new turtle, okay? Make a new turtle called ball. Okay, so ball equals turtle.turtle. That creates a brand new turtle for me to use so I can have multiple on the window. Okay, this makes a brand new turtle and calls it ball. It puts it into the ball variable. So now every time I want to use that particular turtle to do things, I say not turtle.shape because that's the default turtle it's messing with. I say ball.shape, ball.fillColor. Does that make sense? That's what I have to do for all of this, okay? Ball width, kind of. So let me make this happen. So we have ball X, ball Y. So everywhere I said turtle, even if these are variable names, I'm going to say ball. Just to make sure I remember what's going on, okay? And so ball X offset, ball Y offset, ball.up, ball.goTo. Yeah, that's how we're doing this. And so, again, ball X, ball Y. All of these are going to change because I'm going to need similar variables to talk about the paddle's X and the paddle Y, right? I can't just keep saying turtle everywhere. We're talking about just the ball. I need multiple different kinds of variables with the same kind of name. Ball Y, ball width. All right. So I'm just going to do this process until I get to the end, and hopefully I didn't forget any. We'll find out soon once I run the program if I did forget. But this is something that's easier to do in other programs. It's possible to just change a variable once and have it propagate that change to everybody, but we're going to do it manually just so you see the kind of thing that needs to happen here. All of these uses of these variables need to change because I have multiple turtles now, or I'm about to have multiple turtles. Ball X, ball width, ball X. This is the bouncing off stuff right now, isn't it? And then we have draw frame, which is moving the ball X and Y around, of course. Ball X offset, ball Y offset. Ball X, ball Y is changing based on that offset, which is the direction it's moving in, right? We still need to bounce if we hit the wall, and it's finally ball.goto, that new location for the ball to be in, okay? So just to make sure I didn't mess anything up, let me just search for the word turtle. And we'll see, these are fine. To draw the rectangle with the default turtle, that's okay. Boop, boop. Turtle size is fine. Aha, I missed these. So it's got to be ball X offset, ball Y offset. All right, let's see if I did it right this time. Of course not. Ball X, ball Y. Keep going. These are all in comments. And we're back at the top. Yay, okay, so I think I changed all the variables properly. And now, instead of using the default turtle, I'm using the ball. That was a lot of work. Let's see if it paid off. Yay, it all looks fine. And you'll notice that there's a new feature now. We have the default turtle. The last thing I asked him to do was draw the bounding rectangle. So he's just sitting up here with his default shape as an arrow. And he's just chilling there. We can get rid of him if we'd like to. We can hide the default turtle. That's one thing we can do after he is done drawing the bounding box. Hide the default turtle. I think it's just turtle.hide, right? Hide turtle, or HT, there it is. So I can tell him, all right, you've done your work, default turtle, hide yourself. And now in the top left corner, we won't see anything. Okay. So that was a lot of work changing some variables just to get things in the right spots. And now we have to do the rest, right? We have to bring in the paddle program. Okay, so again, we're gonna have to make a new variable called paddle equals turtle.turtle. Make a new turtle, call it paddle. All right? And we have to say paddle.blah. Everywhere we said turtle.blah for that other program. So more variable name changes need to happen now. So, okay, what is the same? So this is the draw rectangle. We don't need to keep that again. But all of this, right? All this, go up, go down. On key press, dot listen, all that stuff. That needs to come into our new program. And so, gosh, I don't know where to put it. Let's maybe put it here. Whee. So, paddle stuff can go here, and then this can be more ball stuff. Okay, so in between these is where I'll put my paddle stuff, and so let's change that around. We need a turtle called paddle. Make a new turtle. So paddle equals turtle.turtle. Okay, and so now every time I say turtle dot for this paddle code, I need to say paddle dot because we're acting on it now. Okay, and just shout out if you have any questions about this stuff. Let me know. And so it's paddle width, paddle X, paddle Y. No, I already am using paddle X and paddle Y. Good job. Go up, changes paddle X and paddle Y, and it moves, though, the paddle, not the default turtle anymore. Not the default turtle. We can, though, just to keep it easier on ourselves, we can ask any of the turtles on our page to listen for key presses and do stuff based on them. So we can just keep using that default turtle to listen for the key presses and to fire those functions off whenever those keys get pressed. So that's important. So let's make sure we do that. So we can just say default turtle dot on key press. We can keep that. That's fine. But it can move the paddle for us. That's what I'm trying to say there. Okay. We can still ask the default turtle to listen for key presses. All right. So let's see. Let me look within here again and see if I accidentally said turtle dot anywhere. Yep, I did it right here. Paddle up, paddle dot go to. All these have paddle in them. All these have paddle in them. And this is fine to use the default turtle with. So I think, in theory, let's try running this. Dun, dun, dun. Oh, is there a problem? Let's do this. Now that's a very interesting bug. Weird. It turns out that the reason our paddle was like taller than it was wide last time was because we used the default turtle to draw that rectangle first, and then we changed him into the paddle. And the orientation of the default turtle was facing upwards. We did everything based on that. And so because this is a brand new turtle, he starts out facing east instead of north. And that is why we get this weird reaction. So all we have to do to fix this is change the direction of this paddle turtle. Make him face north, just like we were doing in our other program. Okay? So make the paddle face north, which is paddle dot set heading. And I think that's 90, right? Because it's degrees away from east in the counterclockwise direction. That looks good to me. All right. So now I have a paddle. It's moving. It has bounds checking. Everything seems happy there. Now what's left is, of course, the hard part. We got to get the ball to bounce off the paddle. Yeah. That's what needs to happen now. And I don't know, should we give the paddle a different color? What do Pong paddles look like? I don't even know. Yellow? All right. Let's see if that is. What'd you say? Is it? Just everything's black and white? That's true. Wasn't the screen black though? Like the background was black and then the... Yeah. I don't think that would be too much to change to get that. But we can make it either black or... Let's try yellow and see if that's actually visible. Well, that's good enough. That's fine with me. So a yellow paddle and a pink ball. All right, so now we need to hook them up together somehow. Once that paddle hits the ball, we have to have it bounce off. All right. I think there's one thing that I want to do before that. Just to give the user a chance, let's make sure that the ball begins its life on the right half of the screen. Just because it could accidentally get like teleported somewhere on the left and start moving immediately, and the paddle won't have time to get there. So I think it would be best if we gave the user a chance at the start of the program and just made sure that the ball starts on the right half of the screen. So that means the x coordinate should be greater than 0 or equal to 0. I think that is what I would like to do. So that's ball x, the initial ball x. Instead of this, between negative 100 and 100, let's make it between 0 and 100. So the ball always starts on the right half of the screen. Of the bounding box, of the rectangle. I don't know. I'll just go back to saying window. And so now no matter which direction the ball starts bouncing off in, it's going to make sure to go and start on the right-hand side of that, the right half of this box. Okay? So I think that's good enough for us for now. And I think what we need to do is hook up that whole paddle bouncing stuff. So let's see. Do I want to do that first? No, it looks like, yeah, the easier thing to do would be to worry about the game over right now. So something new has happened, right, with this game. It's the ball needs to hit the paddle and bounce off, just like we're having it bounce off the wall currently. But if the ball hits the left wall now, that means it's game over, right? The paddle should have hit it, but they didn't get there in time. So that means the game should be over if we ever hit the left wall. That's important, okay? So let's make that happen. So can I get a good bounce? Let me show you what needs to happen. So if we miss the ball and the ball hits the left-hand side, the game should stop. That's what needs to happen now because we lost. So if the ball ever hits the left wall, it's game over. And I think the easiest way to do that is to change our while true, which always draws a new frame, to stop the program, stop the game, stop the while loop, right? When the game's over. So instead of this, let's say while not is game over. We'll have an is game over variable and set it to false initially and eventually change it, all right? So here's how I want to say it. Is game over equals false at the very beginning of the game. Of course the game's not over, it just started. But eventually it might become true. So I want to keep on drawing frames, continuing the game, as long as the game is not over. You see how I'm writing that? And this will just stop the loop, stop the game, once we've lost, once this becomes true, okay? So now our job is to change this when we hit a game over condition, which is the ball hitting the left wall, yeah? So game over should become true. It should become true if we hit that left wall. So let's figure this out. All right. So first of all, where is our check if we hit a wall code? So we keep on drawing frame, keep on calling draw frame, which moves the ball eventually in variable form and in visual form. But it looks like we have encapsulated all of our bounce checking in this function, bounce of hit wall. So that's going to be where we do stuff. Okay, so bounce of hit wall. Which of these is checking if we hit the left wall? Thank you, past me. It's this one. And remember what this means, right? It's all about the ball's x variable. If the ball's x variable gets a little too small, that means it's way over here. It's trying to go past the left edge. Yeah, its center is trying to go past the left edge, which is practically negative 200. X equals negative 200. Plus the width of the ball over 2 because it's always relative to the center of the ball. So that was something like this, right? And this is right when the ball is at the edge, like the paddle missed it. It's always relative to the center of the ball. So it's not exactly x equals negative 200. It's x equals negative 200 plus some change, right? Plus the width of the ball over 2. That's as far as we want to let it go. If it ever goes farther or equal to that, we have hit the left wall. And what we did before was we moved the turtle back inside. We were nice. Like we made it bounce off, right? Move the turtle back inside, change the x offset so that we move rightwards. We bounce off to the right now instead of towards bigger x values rather than smaller x values. So the game should be over now. Technically, I can delete most of this code. We still don't want the ball to go outside, so it's nice to bring it back in, but this I could get rid of because the game's going to be over at that point. I don't need this code anymore to bounce the ball anymore. So I can just delete that. And what I need to add now is this means the game is over. So what I need to do is change our is game over variable to true. And because this is a global variable and I'm changing it inside of a function, it's bounce of hit wall, right? That's the function I'm inside of. Where do I need to be? that means I need to mark it. Is game over is true. We just lost the game, right? Game is over. That is a true statement at this point. I need to say global is game over because I want to change it inside of this function. Okay? So if I set this to true here, it's going to like rein the ball back inside because it's still going to go to. It's going to do that at the end of this call. It's going to redraw the ball. But then it's like, all right, I'm done with the draw frame function. Let me try again. But it checks its condition and oh no, not is game over. The negation of is game over. Well, is game over is true. Not of is game over is false. And oh no, I can only continue if it's true. If my condition is true, now it's false. I'm done. The game is over. Okay? I hope that made enough sense. Please yell at me if it did not. But let's see if we can get the ball to bounce off the wall. Right now there's no collision detection, so it's fine. But let me just pretend I'm bad at this game. Bam. And so the game is over. The ball is stopped. The ball is no longer moving. We're not repeatedly drawing frames anymore. Technically, the paddle is still allowed to move, which maybe that's a feature we care about. We can just keep that. That's fine. But yeah, that is how we can stop the game. That's perfect. Are there any questions about that? There's just one thing left to do. Let's make it happen. All right, so we need to make the ball bounce off the right side of the paddle. And I think the easiest way to do this, to check for this kind of bouncing, is to do the same kind of thing that we were doing here. Like, draw frame is nice, we just call it once, and that's the whole while loop. We had a bounce if hit wall that we called in draw frame. Let's just also have a bounce if we hit the paddle function. That will keep track of all that. Just logically separate all of our problems. That's another problem to solve. So let's have this as well. So if we hit the paddle, bounce off. If we hit the right side of the paddle, of course, bounce off of it. So now we have to talk about what it means to bounce off that paddle. And that is going to be the last piece of this puzzle. So let's make it. Def bounce if hit paddle. What do we got to do? Question. Let's draw this. Okay? So, bouncing off the paddle. Here is my paddle. The paddle always has a x and y coordinate, right? We have taken great care to call wherever the paddle currently is, right? We have called it paddle x and paddle y. That's the center of our paddle. We've kept variables to keep track of that, to make it easier on ourselves. So wherever this paddle is in space right now, its current coordinate is paddle x, paddle y, okay? I don't know the best way to say this. Let's just, I don't know, draw it up. Gosh, what's the best way? Yeah, I'll just use an arrow. So we have, actually, let me put it on this side for a reason. This is paddle x and paddle y. And then we also have our ball, right? Let's say we are hitting it. We want to come up with what is the condition where we do hit this paddle with the ball. So let's say we're just grazing the paddle right now with our ball. And the ball also has coordinates. Kept track of using variables because we were nice to ourselves. It was always ball x and ball y, right? Wherever the ball is, those variables hold that fact. All right, so let us remember that as well. That's ball x and ball y. Relative to their centers, though. All right, so just like hitting the left wall, we need to do kind of the same thing. If the ball's coming in this way, we got to bounce off this way. We'll worry about that in just a second, but we got to remember that. We just need to figure out when we hit the paddle right now. Okay, so let's remember the sizes of everything. I think that's the first most important thing. So if I remember correctly, when we stretched the ball by 2 in both directions, that made the ball width 40, which would mean that the default size of the turtle is 20 by 20 of a square turtle would be 20 by 20 by default. So the ball right now is 40 by 40. Let's remember that. So we got some math to do. 40 by 40. And then the paddle, we stretched in a weird way. Let's see how we did it. Where was that? There it is. No, more ball stuff. Where's paddle stuff? Paddle stuff. We stretched it by 1.5 in the x direction and then 6 in the y direction. So 1.5 times 20 is 30, right? So that's going to be 30. This paddle is width 30 and height. Well, it's going to be 20 times 6, so 120. That is the height of our paddle, okay? And so with this, we can finally determine, like, when does the ball hit the paddle. It's always relative to these centers, though, which we need to remember. Okay, that's ball x ball. This is ball x ball y, and this is paddle x paddle y. So we need one last fancy condition. Yeah, the ball touches the paddle when what is true? Okay, so how do these relate? Like, how do I know the ball is right here, right on the edge of the paddle? What do I know? It's like the distance between them is exactly this much, right? And that's what it means to bounce off the paddle. That's what it means to be right next to it. The distance between them, between their centers, is exactly this, as it's drawn on this diagram. But what is that distance? Say that again? Very good. Yes. That's what we need to figure out. It's those widths, but it's their widths over 2. So we need to figure out what this is. Boop, boop, boop. Those dot, dot, dots. And whatever this is, these dot, dot, dots. If I add those two dot, dot, dots together, I have the distance between the ball and the paddle right when they graze each other. That's where I want them to be. Okay? That is what it means when we touch the paddle. And so I think let's talk about this from the ball's perspective, because like the ball touches the paddle. The ball is the one doing the touching. So the ball touches the paddle when its x variable is equal to what? So here's the ball's x. And how do we compare that to the paddle's x, right? So first of all, this dot, dot, dot is 15. Yeah, that's half of 30. And then this dot, 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 I guess it's not drawn to scale, is 20, right? So that makes this full distance 35, right? So the ball touches the paddle right when its x-coordinate, which is right here, is equal to the paddle's x-coordinate plus that amount. Are there any questions about that idea? That's the key. Okay, so the ball touches the paddle when its x-coordinate, which is referenced by like this line, right, is equal to, relative to the paddle, so here's the paddle's x-coordinate, plus this offset. That's what it means to be right touching that paddle. And so let's code that up. Let's write that in code. It's when the ball's x is equal to the paddle's x. And remember that the paddle is on the left. So you got to go in the positive x direction away from the paddle to get to the ball. The ball's x is equal to the paddle's x plus half the distance of the paddle, which is 15, plus half the distance, half the width of the ball, which is 20. Okay, so the ball is exactly hitting the paddle if its x-coordinate is like this. Okay? We're almost right there. Because of the way that animation works, we might take a jump to be like inside of the paddle as we move, because we move in chunks at a time, right? Multiple units at a time. So actually, the more correct way of saying this, the ball is touching the paddle. It's whenever the ball's x is trying to go even farther than, it's less than or equal to the paddle's x plus 15 plus 20. That'll also save us if it's just slightly inside based on the way that our animations are working. Okay? So if it's equal to, it's definitely hitting the paddle. Or if it's any smaller, we should also consider that to be touching the paddle. Yeah? That's the idea. So that's what we want. Are there any problems with just saying this? The ball touches the paddle exactly when this is true, always when this is true. Because there is something that we have not yet considered. Why is this not fully correct to say this? Any thoughts? So I will draw a nice square in 10 seconds and prove to you that this is not enough. So yes, this is definitely a, what's the mathematical term? This is a necessary condition, right? The ball can't touch the paddle unless this is true. But I think the right term is it a sufficient condition? Is that exactly what we need? And the answer is no, because what if the ball is right here, way up here? Isn't it also true that its x-coordinate is exactly equal to the middle of the paddle plus that amount? So that's what's wrong right now. We'll still consider the ball to be bouncing off the paddle even if it's way up here. So what have we not yet considered then? What needs to rein in the ball and make sure that it's within the paddle? What variable do we need to compare? Or what variables do we need to compare? How do we know when the ball is up here as opposed to within the range of the paddle? There's a cutoff, right? Cutoff are these lines. What axis are these lines along? Very good. Yeah, it's the y-axis. Like if I graph something on the y-axis, it's like y equals 3 is this line. I want to make sure that the ball, if it's above that line, which is the bounding line of the paddle, we don't consider it to be hitting the paddle. Okay? So, just for fun, let's assume that the last spot at which the ball can hit the paddle is like right here. Let's say that the ball doesn't have to be all the way within the paddle, but it should at least touch part of the paddle in order for us to count it as a hit. Okay? So it can be up here, it can be down here. And that is the last spot at which we consider the ball to be hitting the paddle. So let's think about what those y-coordinates are. Okay? So again, it's always relative to their centers. What does this mean? What does this mean? Well, we know that the ball is up here, like this is the greatest range for the ball to be and hit the paddle, if, well, its center is equal to, well, we have, again, the center of the paddle and the center of the ball, that distance. If the distance between, for the y's, for the paddle's center and the ball's center, if it's exactly this, then we know we have hit the paddle. If it's within this range. If it's any smaller as well, it's fine, right? So we need to figure out what is this. That's this height plus this height. So half the height of the paddle plus half the height of the ball gives us this distance, this difference, okay? So that's a lot of words to say that we're within the top range if the ball's y is, well, this is the upper part. So if we're exactly hitting the upper part, if we're equal to the paddle's y plus half the paddle's height plus half the ball's height. paddle y plus half the paddle's height plus half the ball's height, which is 60 plus 20 again, right? And so that means we're right up here, but we want to allow the paddle and the ball to be like this, like this, like this, like this. So anything less than this also works, right? Anything less also works. That means it's within the range. So that's another thing to say. And then we want the ball's y, like we hit it if we're up here or if we're down here, but only within this range. So we need the opposite condition on the bottom too. And that will constrain our y's in the proper way. Okay? So also, we're down here, we hit it at the very edge of the paddle if the ball's y is equal to the paddle's y. And now watch what I have to do. The ball's y is equal to the paddle's y, but now minus this amount and minus this amount because we're going downwards. That's key. So it's going to be paddle y minus 60, minus half the paddle's height, minus half the ball's height because I'm going lower. The ball is lower than the paddle's center, relative. So I need minuses instead of pluses here. So we're right here at the bottom if this is true, but I want everything between up here and down here to count as hitting the paddle. So you're good if you're less than the top and greater than the bottom. Okay, you see how these three conditions, when taken together, if they're all true, that's when we hit the paddle. Exactly when we hit the paddle. That means the X was perfect. We just we grazed the paddle ever so slightly, or because of the way animation worked, we were a little bit inside. So that less than or equal to relative to the X's, talking about the X's. And then also, we made sure that the ball wasn't too high or too low to have reached the paddle. So we made sure like this is the upper limit of the Y of the ball. We made sure that it has to be smaller than that upper limit. And here was the lower limit of the Y of the ball. And we had to make sure that it was above that lower limit. Okay? That's why we have alternating conditionals there. Okay? Comparisons. So if all three of these things are true at once, then we hit the right side of the paddle. Okay? That was a lot to just say that. Are there any questions about how we came up with that? Why this is all the right stuff to say? So again, we noticed that it didn't take a lot of code to add all this functionality. It just took a lot of thought. That's programming in a nutshell. So let's turn this into code now. We know that we hit the paddle if all of these things are true. So let's see here. Can I put all this on the screen at once? Not quite. Let me do my best here. Let me make it small for a second. So we're in the bounce of hit paddle function, and we know we hit the paddle if we're within that range. So if, we have a lot of things, right? So if the ball's X is less than or equal to the paddle's X plus 15 plus 20, if that's true, and, right, and the ball's Y is less than or equal to the paddle's Y plus 60 plus 20, that's the upper part. And it's also true that the ball's Y is greater than or equal to the paddle's Y minus 60 minus 20. Then, only if we're in here did we hit it, right? We hit the paddle, okay? So then we got to do some stuff, but only then, okay? So that's what I want to do there. And we only need to worry about bouncing if we hit the paddle, right? So that is all we need to care about. So bouncing is essentially going to happen the way that we did our bounce if hit wall function. We have some X's, some Y's, and some offsets and things like that. We're never going to change as game over. So I'll keep all this stuff because we might have to change the X's and Y's and things. So I'll add them to our globals list here. And so if we hit the paddle, we got to bounce off the left side. So it was essentially the left wall stuff all over again. So I got to move the turtle back inside of the paddle this time, though. Not worry about is game over, but we have to essentially remember to do this. We'll change the exact numbers in a second. And then we also need to change, because we're hitting the side, right? It's essentially a side wall again. We also have to change the X offset so that we move in the other direction. And it's really rightwards, right? So I move off in the opposite direction. So that's going to be the X offset of the ball. Okay? So we need to move the turtle back inside of the paddle, though. So if it's ever less than or equal to all this stuff, it's got to be exactly this. The ball's X should become, if it's ever smaller than this, it's got to become exactly this. You don't have to really change the Y's or anything because it's not going out of bounds. It's just within the range. But if we ever went smaller than the paddle, that's like we hit inside of the paddle. We didn't want that. We want it to be drawn as if we hit it just exactly. Okay? So that should be what we want here, and it will bounce and move off if we hit the paddle. Are there any questions about how I translated what we talked about into this code? Because I'm not yet sure. I don't remember enough to know if this is going to compile because I have some weird indentation going on because I have multiple ands on a line. I might need to put some slashes here. We'll see. Yep. So because I want a multi-line condition, I have to put some slashes here for a reason. It forces Python to believe that this entire thing is one big line, essentially. This whole thing is on one giant line, and that lets me indent properly and do what I care about. That's just a little side condition. And now, moment of truth. Is it going to bounce off this paddle? Oh, yes. And that is so nice. That is so satisfying. And I'd like to demonstrate that to you more, so let's make the ball move faster. Let's make the ball move faster. So that has to do with the offsets, how fast the offsets are moving, and maybe we can make that offset times 4 in each direction. That'll make the ball move 4 times as fast, which is way too fast. And that stops the game. Let's do twice as much as it was before. I can work with that, but we got a very bad random direction. So let's try it one more time. There we go. All right, so we're bouncing off, up and down, perfectly remembering that it hits it, bouncing off. And even if it's not fully on it, because of the way we did our calculation, we allow it to still bounce off, right? And it's right on that upper edge, that lower edge. And that's how Pong should be, right? But if we ever miss, that really does hit our left wall. There we go. That really did hit our left wall, which is down here. It went too far, past the paddle. So is game over is true, we stop our loop, right? Because our loop is only continuing to draw frames, move the ball, if the game is not over, and it became over, okay? But if it hits the paddle, if it's within that range that we care about when it hits the paddle, then we're just going to totally have it bounce off. Move the ball to be right on the edge, and make sure it bounces off in the proper direction. So, yeah, it's more or less all the code we had before. This is the major addition, really. There's a lot of variable name changes, but this was the one really big new function that we needed to make it all work. That bounce if we hit the paddle. There it goes. And yeah, you can get fancier. You can be like, depending on which, like the top half of the paddle, the bottom half of the paddle, you can have the ball move in a different direction. You can alter the direction. Like if it hits closer to the top of the paddle, it bounces off more upwards, things like that. You can change that all around as you wish. But this is a still functioning Pong game. And this is what it means to hit the paddle, and we are remembering that. You can hold in the keys. One unfortunate feature of holding in the keys is it makes the ball move slower. That is just a side effect of the way we're handling things right now. But you can also solve that with more advanced programming stuff. But yeah, let me lose the game, and that's all that I wanted to show you. Are there any last questions about Pong, how we did it, how we made it work? Game over. All right, so this was my Pong program that I wrote for you today. Your programming assignment is to do exactly what I just did. So for the last programming assignment in this class, which I will release, now let's make sure I'm logged in. Most likely I'm not. There we go. That's why we check. Does it remember my position? Of course not. All right, so your last programming assignment, do the last week class, which is next week, next Friday-ish, right? May 13th. Yeah, Friday the 13th. That's fun. We have one of those this month. So, for your last programming assignment, implement Pong. Follow what I just did. Do it all over again. That's why I'm not giving you the code. Hopefully, by typing it up yourself, you will realize some things that may not have been fully apparent as I was coding it today. So, yeah, upload a video, show me that it's working as it should. If you'd like, you can do fancier things, change the colors every time you hit the paddle or something. Go crazy if you'd like, but all that I want to see for credit is what we did today. Okay? So, that is your final programming assignment. We have come so far. Are there any questions about it, what you're being asked to do? All right, well, if there are no questions, that is all I have for us today.